We'll start from the top. Number 1, the square root of 48. You're being asked to simplify. Now, I admit the word simplify is a little bit ambiguous. Sometimes it means one thing and sometimes it means another. But at this point, you can see everything is underneath the square root. And we're trying to see if we can take anything out from underneath the square root. So this working here, pretty outstanding. Who wrote this down? Who wrote this? First one. Oh. Good work, Jay. This is flawless. So have a look at how he's done it. Maybe you skipped 1 or 2 of these lines and you still arrived at the right answer. That's not necessarily a bad thing, but I really like that all the lines are there. First line, he's looked at 48 and he's just broken it up. He's factorized it. He chose 16 and 3. It's not the only way you could do it. You could do 2 and 24 or 4 and 12 or 6 and 8 or... I think that's most of them, okay? But he's chosen 16 and 3. It's a good choice. Why? Why 16 in particular?
Because it's a square.
16 is a square number, and not only is it square, it's the biggest square you can fit in there. 4 is square as well, but once you take 4 out, well, you can still take more stuff. So he's taken out 16, good choice. He's then separated 1 square root into 2. Do you remember that? This is the last sort of law that we looked at yesterday. So he's broken it apart, and then he's saying, I know what root 16 is, and that's perfect. So good job if you got 4 root 3. Let's have a look here. You can see some of it's been skipped over because we've gone straight to 2 square roots, but it's still looking okay. Do you agree that 16 times 20 is 320? Yes? Looks okay? It's okay if the first square you think of isn't the biggest one, because you can see the next line. Who wrote this one? Who wrote this one in blue? Okay, Ariba seen. Oh wait, but I can break up 20 further, so that's cool. He just keeps on working at it. This becomes 4. He's broken this into 2. That becomes 2. 8 root 5 looks perfect. Yep, thumbs up. Cool. Okay, so you're getting the hang of it. Let's start to go through a little more quickly. The square root of 200. You can actually just see 100 quite quickly, and you can take that out, the square root of 100, as 10. Then what happens here? What's this about? What's taken place? The 10 on the numerator and the 5 on the denominator. There's a common factor there, so that's what's been cancelled, leaving with 2 root 2. Perfect. Okay, and then we have some squaring to do. If you have a look at this line here, and this line here, these are the important ones, okay? These are the ones where I can see your mind working and that you know what's happening when you're squaring the whole thing. 4 and 5 is this squared and this squared. 9 and 7 is this thing and this thing being squared, right? That all checks out. Good job. So if you've got all of those, congratulations, you can rule that off.
Whenever you type like negative something squared, it always comes up with a negative number.
Okay, so glad you mentioned that. If what you did was type into your calculator, just as an example, this gets at that problem we worked out with the mixed numerals. Do you remember that? Do you remember when I was typing a mixed numeral like this? Do you remember when I typed this into my calculator? If I typed it the wrong way, it would think what I meant was 1 times 4 over 5. Do you remember that? If I punched the numbers incorrectly, okay? Now something almost identical is happening here. If you meant to do negative 5 times negative 5, then what you want to type is this, okay? When you do this, it says, ooh, order operations, that's minus 5 times 5, yeah? So that's why it hands you, in that case, minus 25, right? So just be careful when you're squaring and you've got negatives, it's a good thing to stick with. If you have already ruled off, the heading I'd like you to make is adding and subtracting surds. So before we get to adding and subtracting surds, I want to look at adding and subtracting another kind of number. If I said to you, actually let's make it more interesting. Let's go minus. If I said to you, can we calculate a half minus 3/7? At the moment, in their current form, without a calculator, I can't do this, right? I actually have to fiddle with these numbers a little bit. I have to change what they look like, okay? Can you tell me how I should change them? Arif, can you tell me what to do? Yeah, okay, so I'm going to change the denominators and stuff. You had your hand up as well. How should I change the denominators?
Like 14, this is the lowest common.
Yeah, perfect. So if I make this over 14, I'm pretty sure it's 7 over 14. Agreed? Yeah. What about this one?
21. 21 over...
To get the denominator 14, I've got to double it, which means I should also double the numerator, so it's 6. Happy? Yeah. And now, of course, I can actually calculate it. Okay, bless you. Now, the reason why we had to do that first line, get the common denominators, is because these guys don't like to play with each other, right? Those different denominators, they just don't mix, so no problem. You convert them, and then off you go. Bless you. However, when it comes to surds, right? If instead I gave you, say, root 2 minus root 7, okay? How do we simplify this? And the answer is, well, you can't. Fractions, these guys don't like to play with each other. That's okay, we can rewrite them and then they will. But surds, the most antisocial numbers that are out there. Root 2 and root 7, there is nothing you can do to make them play. In fact, that is as simple as it gets. This is fully simplified. Okay? So if you've got surds and the number underneath the square root sign, by the way, I've waited until now to tell you what that square root sign is actually called. It's called a radical sign. I'm not even making that up. It's called radical, okay? If the numbers underneath the radical signs are different and you can't change them so they're the same, then that's it. That's as simplified as it gets. Root 2 plus root 3, that's it. You can't add them together in any way. Okay? However, we can sometimes adjust these so that you can. So underneath this, different example, e.g. What was the one you just did? Oh, I remember. Okay, so have a look at this one for a second with me. Now, it looks kind of like the one I just showed you, right? In that the number underneath the radical, underneath the square root sign, they're different, okay? But we did that first one in the review questions, right? I can muck about with that a little bit. How can I rewrite the square root of 200? What would you like me to do? Yeah, Delight.
200 times 2.
Okay, so that's 100 times 2. Do you agree with that? Plus 3 root 2. As you become a little more comfortable with these, I think I'd be okay with you, if you can do it reliably and accurately, I'd be okay to go straight to 10 root 2. Do you see where I got the 10 from?
Yeah.
Yeah. That's the square root of 100. Yeah. So that's 10 root 2 plus 3 root 2. Okay. So even though they didn't start with the same number, now they are. And this is actually a lot like algebra. Do you remember in year 7, when you first encountered algebra, you learnt about collecting like terms? Does that ring a bell? Collecting like terms? Yeah. So we were like, oh, if you have x's, right? Those guys can mix together, that's all good, right? Well, these guys are kind of like x's, the root 2's, and so I can collect them. 10 here, 3 there, gives you 13. Root 2. Okay? So just like here, 5x plus 3x isn't 8, it's 8x. This is 10 root 2, 3 root 2, together is 13 of them. Okay? If I had some other guys hanging around like a root 3 on the end, is there any way you can twist and turn root 3 so it can mix together with this? No, you're kind of stuck. So therefore it stays. You have to look carefully at these numbers and say, well, can I work with these? Let me give you one more example, and then we can actually start on the exercise. So this is the last quick one we'll have a go at. Then you can practice a little bit. none of these surds at the moment, have the same number underneath, okay? So I can't do anything with them at the moment. However, if I try and move them, twist them a little bit, just like the square root of 200, maybe some of them will end up as the same kind of surd and I can collect them. All right, square root of 98. Can you think of a nice big square number that divides into 98? 49, very good. So this is actually the square root of 49 times 2. Okay, I'll put that to one side. I'll simplify it in a minute. What about the square root of 18? Can you do something with that? That's 9 times 2, isn't it? Okay, last one. What's the biggest square number you can fit in 32? 16. So it's 16 times 2. Yeah? Okay, let's simplify. This is 7 root 2. This is 3 root 2. And this is... Cool. 8. Yeah? Cool. Okay. So, if you see them all combining together, then that's great. If I had just, something like this hanging off on the end, the square root of 7, plus the square root of 7, plus the square root of 7, plus the square root of 7, there's no way, there's nothing you can take out of the 7 to change it into a different number that will make these guys the same. So you just leave it there, and that's okay. It's fully simplified. All right?